So, Mr. Kane here, and the microscope. This is how we go about looking at cells and other really small stuff. So, what exactly are they, how do they work, and what's the best way to use them? Let's have a closer look, pardon the pun, at microscopes. So, a little bit of history. Lots of people were trying to make them back when they were making telescopes, probably invented by accident, because they were looking at stars and probably put lenses together and discovered they magnified the really small things as well. First one was huge. Okay, it's like they were building big telescopes too, so the first microscope was probably just as big. Now, lenses that they use in microscopes have been around for a very long time, and people probably first noticed the curvature of water droplets magnifying things. A bit like that movie The Bug's Life, with he has a water droplet rolled up in a leaf as a telescope. So, a bit more history. Who's that guy? Yeah, Zacharias Janssen. From Holland, Dutch guy. The Dutch were very good with their lenses, glasses, telescopes, sailing and stuff. They're very top of the game around this sort of time period, so naturally also very good at producing lenses for microscopes. That's supposedly the first microscope, and as you can see, it looks very much like one of those slide in, slide out telescopes that we see pirates on ships using on movies on TV. So very close parallels to those. Bit more history. So we've got Janssen creating the first one, and then these guys here, Van Leeuwenhoek and Robert Hooke, making improvements. So Anthony, Robert Hooke, English guy, and the Hooke microscope. Quite similar, but mounted on a base, which helps it a bit, which is one of the big improvements that's happened to microscopes. So how does it actually work? What's going on? So lenses, chunks of curved glass, they make microscopes and telescopes and spectacles, glasses as well. And what they're doing, they're bending light and focusing it to a point. As you can see in the diagram here, the light's coming through the lens and all being focused to one point. And magnifying things, so we can use it to magnify whatever we want to look at. And if you use them in combination, we can increase this magnifying effect. So there's a typical microscope, pretty old school. Now if you look at it, this part here is basically the same as the very first one. That bit inside that circle is the microscope. That's the bit that does all the magnifying. Everything else is on there. Where are we? Everything else, all this part here, is just holding the light, guiding staff, the stage to put things, and we'll learn about that soon. But it's this bit here, that is the microscope. That's the bit that does all the work magnifying. The rest just hold it in place and makes it easier for us to use. So what do we got? An objective lens. That's the one looking at the object. That's how I remember it's the objective lens. They come in different sizes, and they're gathering the light and sending the image up through that body tube. So the body tube, I've pointed out before, okay, that's where the image focuses inside there. We've got an ocular or an eyepiece lens at the top. Okay, as we look through, magnifies it again and into your eye at the right size for your eye. Right, that's the basic guts of a microscope. Let's look at the bits in more detail. What else we got? So the body tube on this one. Okay, you can see this one here. There is your microscope. That's where all the magnifying does. All the rest of it, all this stuff down here, that is just support network for helping you with the other stuff. What else we got? A nose piece. This contains your objective lenses of different sizes. There they are on there, and you can see there's 3 on there, and there'll be different sizes for different amounts of magnification. A couple of stage clips, and they hold your microscope slide in place so it doesn't move around. Diaphragm adjusts the amount of light coming up from beneath. It could be an electric light, as in this case, or some older microscopes use a mirror to send light up through the bottom there. The diaphragm adjusts how much light goes through. There's your eyepiece lens. That's the one your eye goes into. Objective above the object you're looking at. Ocular and eyepiece, the one your eye goes to look through. We've got the arm. The arm simply holds the body tube and the magnifying lenses at the right place. We've got a stage. Okay, everything performs on the stage, so the microscope slides, the things you're going to look at will be put onto the stage. We've got a big adjustment knob for adjusting the focus very carefully and roughly up and down, and there's a fine adjustment which moves it just a little tiny amount, and the whole thing rests on the base. There's all the parts of a reasonably modern microscope. So, magnification. How do we figure that out? So we're looking at a slide. We just simply multiply the eyepiece lens by the objective lens that you happen to be using. So they've got their magnification written on there. So somewhere on the lens around the base of it here will be a number. It might be 10 times, it might be 20 times, it might be 40 times. Be a number written in there somewhere. Okay, on there somewhere. So ocular eyepiece lenses, now that is up the other end of the body tube, up around here somewhere, and they usually magnify by about 10 times. You multiply those two numbers together and you'll figure out your magnification. So if we're using the eyepiece lens at 10 times, the 40 times objective lens, 10 times 40 is 400, so your object is being magnified 400 times. That's how you figure out your magnification. Looking after it. They're quite expensive beasties, and the lenses are what most of the cost goes into. So only with special microscope cleaning cloths and tissues, the kind that you use for your normal eyeglasses, think they're not going to scratch the lenses. Usually best to get the teacher or the science technician or the person who looks after the microscopes to do it for you. Never touch the lens with your fingers. Fingers have got finger grease all over them, and that sticks on the lens and it's very hard to get off. When you're using it, make sure it's on a flat surface so things aren't going to tip over and fall over and bang them, because you don't want to bang it. It puts lenses and arrangements out of alignment, so it doesn't point in the right direction. Carry it with two hands, one on the arm, the other on the base. Like this gentleman here is doing. He's got one hand beneath the base and the other hand is holding around the arm, or some people call it the neck of the microscope. So he's got it supported underneath and on the arm, so he can carry it carefully where he's going to go. Using it carefully. Always start on the lowest possible magnification, the smallest objective lens, eyepiece lens. Don't even worry about focusing it. Don't even worry about having something on the stage. The first thing you want to do is make sure you've got light coming through it. These are light microscopes. No light, you're not going to see anything. And how many kids have I seen standing in front of the mirror and saying it's really dark, there's no light coming up my microscope? If it's an electric light, make sure you can get a lot of light through it before you even start looking down it. It's easier to adjust it downwards later on, but you want to adjust the light source to its maximum to start with. Put a slide on the stage, put it under the clip so it can't move around and fall off. Then use your coarse focus to adjust till the image is clear. Okay? Up or down, whatever you need. Just be careful you don't bang the objective lens into the slide. Okay? Don't ever do that. When you go to higher magnifications, always only use the fine adjustment, because the objective lens will be so close, it'll be a fraction of a millimetre away, and when you only use the fine adjustment, otherwise you will crash into the slide, you'll break the slide and you can scratch the lens. Okay, so only use fine adjustment when you're using the higher powers. If you can't see it at higher powers, go back to the lower power, refine what you're looking for, refocus on coarse focus at the lower power, then go back to the higher powers, back to fine focus. If in doubt, always go back to lower. So that's the microscope. Thanks very much for watching, and hope it was helpful.